get a fancy lunch. All right. Yesterday was step one. Some of you heeded my advice to redraw the circuits. That will prove beneficial. Say that. So, by the end of the step or end of the lesson, you'll be able to calculate the voltage, current, power, and a single resistor in combination circuit, and employ Kirchhoff's loop rules for circuits. All right. Step one is find the equivalent resistance, or like boil this down to one resistor. Make sure you redraw. I'll give you a minute head start. Go. On your paper. Like it's not going to be good. You're like, yeah, I can do this eventually. Not get a chance. You're not going to be able to. The redraw is essential. How do you? 15 ohms. Okay. Now, that is step one. On the redraws, I'd recommend putting your units because you're going to have a lot of numbers. Okay. So, here's how we proceed. Every resistor that I care about, I want to know all three of these things. Voltage, the current, and the resistance. For each resistor that I care about. Okay? So at this circuit, I got a 15-volt battery. So voltage gain equals voltage drop. That means I have a 15-volt drop across that resistor. Okay with that? And then the last thing, I have voltage, I have resistance, I need current. Well, that was convenient. 1 amp. So I know there is 1 amp going through here. So now I have all three of those variables for the resistor I care about. Okay. Now, here's where the redraw comes in, essentially. The 15 ohm came from the 10 and the 5 wired how? Series or parallel? In series. What measurement is the same in a series circuit? Current or voltage? Okay, this is what has to be memorized. Ready? Current is the same in a series circuit. So, everybody got that locked in? Don't forget that. Okay? So, I'm going to take the current from this previous step and apply it to both of these. There's 1 amp going through this one and 1 amp going through this one. Okay, so current is the same because they're in series. There's 1 amp going through here. This one came from these two wired in series, so there's 1 amp going through and 1 amp going through. Conceptually, does that make sense? Okay. So, I want to know how much current's going through the bulb 2. Where's bulb 2 buried? In the 10 or the 5? Buried somewhere in the 5. So this is the resistor that I care about. I need to find all three of these things for the resistor I care about. Okay. So I have the resistance, I have the current, I need the voltage. That's not hard to do. We're just going to use Ohm's law. 1 amp times 5 ohms. 5-volt drop. There's 5 volts across that. I now have all three things for the resistor I care about at that level. Okay. The 5 came from the 2 and the 3 wired how? Series or parallel? Parallel. So what measurement is the same in a parallel circuit? Current or voltage? Voltage. So the voltage I get here across this resistor is the same across here and here. So I have 5 volts across this and 5 volts across this. Right with that? Okay. I'm looking for the current going through the 2. Well, I have 5 volts and 10 ohms. So I found that to be 0.5 amps. And that is my answer. pattern there? How we're doing that. Or the procedure. And why the redraw is important. It gives you the steps backwards. Here is the most popular wrong answer. Most people can boil it down to 15 ohms. But then once they get this, they're like, "Ow, I'm gonna like forget all this backtracking. I'm gonna jump straight away to here and try to answer it with this and not going backwards." That is the most popular answer, which will be on the test. Make sure you're not one of those. Does that make sense? Okay. In case you missed any of that, on the slides, this is how you bake a combination circuit problem. This is everything I just talked you through. Okay, on your slides. So I want to use this example, kind of show you proof of concept of Kirchhoff's loop, of the loop and the junction rule. So I'm going to calculate everything for every resistor in this circuit. So I've got all three things for this guy. We have 0.5 amps going through this. This is identical, so this is 0.5 amps going through that. This guy, number one, at this level, I can find the voltage. There's a 10-volt drop across this guy. 10-volt drop. Okay. And because there's a 10-volt drop, there's going to be a 1 amp current going through. You have 10 volts, 10 ohms, 1 amp going through that. Okay. Now, Kirchhoff's loop rule says the voltage gain equals the voltage drop. So here's one loop. Voltage gain of 15 volts. Voltage drop of 10. Voltage drop of 5. Checks out. Here's a second loop. Voltage gain of 15. Voltage drop of 10. Voltage drop of 5. Checks out. Okay. Here's a junction. Going through this, 0.5 amps. Coming out of there is 0.5 amps. Going into here is 1 amp. Going in, 1 amp. Going out, 0.5 plus 0.5. Okay. That same conversation could be had for that junction. 0.5, 0.5 going in, 1 coming out. That will always work. Okay? Good for this to go away? All right. Give you a head start. Make sure you redraw. Find the equivalent resistance. Simply finding the total resistance is not going to be sufficient. You need to redraw this. How'd we do? Okay? Okay, that's checkpoint number 1. There's 9 amps coming from the battery. I want to know the power through dissipated by this guy. Beat me to the end. What do you get? Minute head start. You want to find the voltage, the current, and the resistance for every resistor that you care about each step. Checkpoint 2. Checkpoint 3. Finish line. Grade yourself out of 5. How'd you do? Watts. Okay. Do you see what you got wrong or where you got it wrong? And you see why makes sense why my answer is right. Okay, questions, points of confusion, you can just point and go, huh? Why'd that work? How'd you know how to do that? Or like, where did that come from? Something. It'll be beneficial for others.
How did you get 4 over 3 for the resistance?
So I've got 3/4 for 1 over the resistance, and find the reciprocal. So the reciprocal of 3/4 is 4/3.
How did you get 3/4?
9 over 12. And reduce that.
Did you just multiply the bottoms?
No, I added the fractions.
But like multiply 1 over 6 is 2 over 12.
So I did 2 over 12 plus 4 over 12 plus 3 over 12. Good. Other questions? Okay. Ready for this to go away? Okay, this one's a little different, actually quite a bit different, but you're going to use the same rationale. Here I gave you information about the current and the resistance of a single resistor. Here I was giving you stuff about the whole circuit. Here, so you're going to use, here's just my little nudge, you're going to use what you know about this circuit and start making conclusions about resistors, other resistors in the circuit. So using this resistor and that information, make conclusions about others. I'll give you a little nudge. Twelve volts. Okay with that? How is the 6 ohm and the 3 ohm wired? Parallel. What measurement is the same in parallel?
Voltage.
I'm glad I get that on lockdown, kids. Voltage is the same in parallel. So, 12 volts across that. So on this one, you're not you don't need to boil it down to one resistor. Because I gave you information about not the whole circuit, but just one individual resistor. Let me give you a little another nudge. That's a junction. Thumbs up when you have an answer. Tell your neighbor and tell them how you got it. Correct answer is D, 6 amps. Okay, here, this gives us 4 amps going through here. There's a junction here, that's 4 amps going through that. We had 2 amps going through this guy, which was given. So, through this one, there needs to be 6 amps going into that junction. How do we do it? Okay? So, a little different strategy, but using same concepts. Okay? So if I give you information about an individual resistor, don't boil it down to one. Start making connections. Thumbs up when you have a guess. Tell our neighbor what you think. Correct answer is I got a vote for 3. I got a couple votes for 2. Got a lot of non-committals. Got another vote for 2. Correct answer is 2. Okay, here's the story of the current. Ready? Everybody comes out of the battery. Yeah! Everybody has to go through A. Yeah. Oh, fork in the road. What should I take? Most of them go the path of less resistance. Some of it goes that way, through more resistance. Okay with that? And because these are in series, they have the same amount of current. Good? Okay. Got a worksheet on Monday. May I introduce to you a take-home project that'll be due right before spring break. I'll post this information on Canvas as well. You're going to be designing and wiring a kitchen, a model of a kitchen. You're going to be using Christmas tree light bulbs as the resistors. It's going to be powered by batteries. You're going to be wiring them with some wire and Christmas light bulbs. Like, where am I going to get Christmas light bulbs? The assumption is you probably have some Christmas lights that don't work. Harvest them. If you don't, I've got trash bags full of Christmas lights you can pay. You're going to be hooking, so in your kitchen, your oven is wired to a separate circuit. Like, it has a separate circuit breaker. The rest of your kitchen is wired some like another. So what I want, I think I have like 4 appliances wired in parallel, and then the oven on a separate circuit, all powered by the same battery. I want to fuse something that represents the fuse, for one for the oven and then one for the rest of the kitchen. You're also going to research how to do a two-way switch, which means you can come over here and turn off your light on one side, turn it off and on one side, and turn it on and off on the other side. And you're going to wire that for a light in your house or in your kitchen. Your kitchen can either be, like, this is the it doesn't have to be three-dimensional, but it can.
I worked in last room. She's 7 tall.
Alright.
That's my next class.
Yeah, partner within this class.
Oh, you mean like on that end or on this side?
That's a great question.
Partner within this hour.